today we have David Johansson. He comes to us from London. He most recently spoke at AppSecUSA, and he's going to be, as I mentioned, talking about cookie security. He works for Synopsys, and he's trained hundreds of developers on security topics. And is there anything else you wanted me to mention about you? He's an awesome guy. We just met. And without further ado, he's got a lot of material to cover, so I'm just going to give it to him. Thank you.
Okay. Thank you very much.
You have the mic.
I have the mic. Hope you can hear me. Hey, good morning, everyone. Good to see you here. I enjoyed the dinner and the fireworks that we had. And today, I'm going to talk a bit. My name is David Johansson, and I work for Synopsys. I help clients to design and build secure software and also develop and deliver various trainings. And I'm based in Sweden, but living in London since about 3 years now. Why talk about cookie security? So, as web developers, we know that cookies play a very important role in many web applications, and they're basically used everywhere. Oftentimes, they also have quite important aspect in terms of security. They're used to track authenticated sessions. They are used times for sensitive data. They're also sometimes used to types of security features and mitigations, CSRF. The problem with cookie security is that it's actually somewhat broken, and there are some things that doesn't work as well as we might assume it is. Most of these things I will cover today are developers, security professionals alike. Many of them don't seem to be aware of all of these issues, and they sometimes have some false misconceptions. Security features provide in terms of protection. And hopefully you will learn something new, and you will have some more things to think about when it comes to cookies. The agenda for today is first to start off a little bit with cookie basics. We're going to talk a little bit about cookie history, where they come from, how they're used, and some failed attempts to improve cookies in the past. Then we're going to talk a bit about in terms of cookie security. They can affect it like secure attribute, HTTP only, and so on. And you're probably familiar with them and heard most of these before. In the end, we'll also talk a bit about some recent advancements in terms of cookie security and some initiatives in terms of upgrading the security of cookies. I'm going to talk about things like same-site, strict secure cookies, and cookie prefixes. Let's just roll back in time a bit, talk about cookie basics. What are these cookies and where do they come from?
Hey, David, your mic's hitting it.
Okay, sure, we can do that. Let me see.
That one is just cutting out. We'll switch. That mic's pretty good.
Yep. Okay, do you hear me better now? Yeah, I can hear myself as well now. Good. Okay, so let's start with the history of HTTP cookies. So HTTP cookies, they're actually based on a quite old recipe, you could say. Back in '94, they were created, and it was an engineer at Netscape who came up with a draft about storing information on the client side, because the client of them, they want to store some information state on the client rather than on their server. And that's where cookies come from in terms of HTTP cookies. And then later on, people started to implement this. So Netscape were first, and then came Internet Explorer, and soon cookies became more widespread. But it was not really an official standard, and the draft itself had some warning about, yeah, this is just an draft and use with care kind of notes. It was just 4 pages and left a bit of things unanswered in terms of how to implement certain details. So there were some attempts done later on to try to mitigate this by creating a formal specification. So RFC 2109 came out in '97, And it had some improvements, and this time people started to be aware of cookies and the potential privacy impact it could have. And for example, they added things like a comment field in a cookie, which the server could use to specify its intention for why it was setting this cookie. The problem was, though, that no one really started using this. No one implemented it. So the browsers, Netscape and Explorer, they didn't care about this RFC, and they kept on using the old-style Netscape type of cookies. So a second attempt was done in 2000, RFC 2965. It introduced, again, a couple of new things. For example, a set cookie to header and a cookie to header from the client. Anyone seen those in applications today? No, it's very rare. So these are things that were an attempt to change how cookies were used and introduce a new version. And one interesting thing, if you read this one, is the version that's set in RFC 2965 is set to 1, which was the same version that was set in RFC 2109, although they worked completely different. And that's probably telling why the first one never got off, because no one used it, so they kept the version number but changed the specification. But again, no one really used this. No one implemented it. And most people and browsers, they still relied on the old Netscape draft. Not much happened then again until 2002, when Microsoft introduced HTTP-only attributes. So this was something introduced in, I believe, Internet Explorer 6, Service Pack 1. And what it did, as most of you are aware of, was an attempt to protect against some of the impacts of cross-site scripting. In terms of when someone injects a script in a cross-scripting attack, a common way to steal someone's session was to steal a session cookie, and then attacker could use that to impersonate a user and hijack their account. So by introducing HTTP only, they try to prevent this attack type from being carried out with cross-scripting by preventing the browser from making this cookie available to a script that's been injected into a page. And it took a while before other browsers followed, but eventually all browsers adopted this, and now it's part of all browsers. Then it took quite a long time before something more happened, and it was not until 2011 that RFC 6265 came out. So at this point in time, it was quite different from the previous attempts of specifying a standard for cookies. So before, they were trying to specify a prescriptive standard of how it should be done and improvements to cookies. Whereas now it seems like they're kind of given up to, okay, browsers and web developers and applications are not going to listen to what we say they should do, but now let's try to document how it's actually working out there in real life. So that's basically what RFC 6265 is doing. It's trying to document a way that's specify how cookies in general are used on the internet, and to make new clients able to implement it in a way that's as compatible as possible with existing services that are out there already. So it's not so much that the browsers would implement 6265, but rather the 6265 implements how browsers actually are working. And of course, browsers are working a little bit different in terms of cookies, and that's why not all browsers work the same. For example, the MaxH attribute was introduced in 2109, not part of the original draft from Netscape, was never adopted by Microsoft. So IE, for example, doesn't support that. Other browsers that may support both the old expires attribute and the MaxH attribute. In practice, from what I've seen, most people just use the old expires attribute. Then today, there's finally some more improvements in terms of cookies and specifications. So there's ongoing work, most recently the update to RFC 6265. For example, Mike West from Google is working on that. So this, I think the last one came out in August of this year, the second draft, which combines some of these more modern cookie protections that some browsers have implemented that I will talk a bit about later in this talk. So there's some good news as well. So how do cookies look? What are they? Well, cookies are typically sent in HTTP headers. So one way to set a cookie is from a server response. The server can set a cookie with a set cookie header. And then subsequent requests from the client, it will then include these cookies in a cookie header. And of course, cookies can also be set client-side through JavaScript. What's interesting to note here is that we have various different attributes, as you can see, that a server can specify on a cookie that influence how these cookies are managed by the client. And then what's also important to note here is that when the client then sends these cookies to the server, these attributes are no longer there. It just sends the value, the name and the value of the cookie. So let's start to go through a couple of these attributes and look at how they work. So if we start with a secure attribute, it's basically a thing that was introduced to try to prevent this cookie from being accessed by a man-in-the-middle attacker. So sometimes when I meet people, both developers and security professionals, I have this misconception, I would say, that cookies are marked with a security attribute only sent over an encrypted HTTPS connection and therefore safe from man-in-the-middle attacks. So what do you make of this? Is it true or false? Any hands? Show of hands for true. Anyone would say it's false? Okay, a lot of you. Okay, so it's both true and false. It depends on what you mean with safe. It depends on what you look at. So it's actually true in terms of confidentiality, because a cookie marked with a secure attribute will not be sent on an unencrypted connection, so it will only be sent an HTTP connection. So it does provide confidentiality protection. What it doesn't provide is integrity protection. So if we have a man-in-the-middle attacker here, Mallory, for example, that is able to intercept communication between Alice and Bob, Mallory can't read these secure cookies when they're sent from the client Alice to the server Bob. However, in any type of clear text communication, Mallory can still write or change these cookies. And that's important because some applications I've been looking at, they assume that the values in those cookies are secure and safe, and they are what they set them to be. And they may, for example, include them unencoded in the output, which could open up for cross-scripting attacks if an attacker would overwrite it with some malicious content. It's also important in terms of, for example, session fixation. If an attacker can fixate the value of a session ID for an unauthenticated user before they have authenticated, and the server doesn't rotate and update the session ID, then that could be used to plant a cookie on someone and then have them authenticate and elevate the privilege, and the attacker now has knowledge of an authenticated session ID. Also in terms of CSRF protection. So cross-site request forgery, as you know, is a result typically of a process including all the cookies to a website for where the user is already authenticated. And if the user is tracked by these cookies, the attacker can create a cross-site request that would perform an action on the user's behalf without the user intending to send this. But because the browser would automatically submit all the cookies it has for a certain site, then it would perceive it as being a request initiated by that user. So one of the defenses against this type of attack is called the double submit cookie pattern, and it's quite popular in terms of that it's stateless from the server's point of view. So the server can set a different cookie separate from the session ID with a random token or nonce, and then it can also include that in a legitimate requests, and then it can verify on the server side that both of these matches. And if they do, they know that it's an intended request from the user because he was requesting the first page and got the right token to include. But if it doesn't match and doesn't contain the right token, then you can reject it as a cross-request forgery attack. The problem with that is that it's based on the assumption that because an attacker can't read this cookie, then he can't create a valid request and include the right token. But what if an attacker doesn't want to read the cookie and doesn't need to read the cookie? What if it just sets the cookie instead to a chosen value? Well, if you know what value is in that cookie, then you can also create a request with a corresponding right value to bypass this protection. So that's what I intended to try to show you in a quick demo. So let's just switch with this. So let me put this over here. Okay, we'll try to do this one-handed. So here we have a very simple app. Looks like something from '94 when cookies began. So I was just putting this together last night. So we have like a profile page. So let's say we have a profile page where we can then also update our email. So if I go here, I can change to something new. So if I update this one, we can see that it's changing the email for my user. And if I now go to this update email function, we can have a look at how it's the source. And we see that this app is actually protected against cross-site request forgery. And the way it does that is with CSRF middleware. It's a Node.js application. And we can see it's added a value to the form here. So if an attacker now tries to perform a man-in-the-middle attack, let's say I'm on the evil domain, and now, of course, a real attack would not be visible to the user. It would just be that the browser page that would perform this. But in order to show this a bit more, I've made this form visible, and also that you have to click on it. So if we look here, we see we have a form pointing to the same target endpoint and with a predefined value. And if I now try to update this, we'll see that it's not possible because of this cross-request forgery protection. So because we didn't have a valid token, it was not possible to perform this attack. So what if we provide our own value? So now I've set a specific value that I've calculated. And if I now try to perform this attack again, we see that it still fails. And of course it fails because I don't know the exact value should be there because I don't know what's in the cookie. And that's basically how the double submit cookie pattern works. It's based on the assumption that attacker doesn't know what's in the cookie, so it can't create a request with the right value. So how can we defeat this then? Let's go back here and let's say that we would try to perform a man-in-the-middle attack. So I've simulated this by using burp. And in this case, I just pass through all the HTTPS requests. So I'm not going to intercept HTTPS traffic. So I'm just looking at HTTP traffic to simulate the capabilities of an attacker that has network level access. So let's start to intercept the requests. And let's say we would go to this site, and then we would access it over plain HTTP. So we see here that it makes the request from the browser. So if we forward that one, we see that the server itself, it just redirects to the HTTPS URL. It's only a redirect in HTTP. But in this response here, what we could do is we could try to set a cookie now. So let's say I add this, and then it needs to be the right value. So it's called CSRF underscore. So let's set it to A, because it was for the token A that I calculated the corresponding token value that needs to be in the form that I showed you in the attack payload. So let's do that. We can set it for the path here. Oh, sorry. We need that one as well. OK, so that should work. So let's set this cookie. So we can still see now that, OK, I got redirected, and I'm now back. And I see my email was what I was setting before in the legitimate app. Now we can go back to the attacker side. So if I now try to perform this attack again and set the new value of the email to hacker at evil domain, we see that it actually worked, and it accepted this cross-site request forgery attack, and it updated my email. And the reason for this here is that I overwrote the secure CSRF cookie with a value that was in there to protect against this attack to known values. Now I knew it was the value A, and the attacker could then calculate the right value to include in cross-site request forgery attack, and thereby bypass this protection. So what I want to make sure you understand here, the point I'm trying to make is that the integrity protection of cookies is very weak. So secure protects the confidentiality, but not the integrity in browsers. Okay, so let's move on to the next topic. It's the HTTP-only attribute. So this was an attempt, as I said, by Microsoft in 2002 to keep the hands of JavaScript away from the cookie jar, to prevent the JavaScript from being able to grab this cookie in a cross-scripting attack and send it over to the attacker. So sometimes I hear things like this: cookies marked with HTTP-only attribute are not accessible from JavaScript and therefore unaffected by a cross-scripting attack. Again, what do you say? True or false? Show of hands for true. Good. 1, 2, 3, a couple. Yeah? That's good. How many believe this is false? No one? Okay. So again, it depends. In theory, it does work, and it does protect the cookie, and it prevents, according to specification, there shouldn't be any access from a non-HTTP API to HTTP-only cookies. So a JavaScript should not be able to either read or write this cookie. In practice, though, it only protects confidentiality. And the way we can do this and overwrite a cookie is by simply not overwriting the value directly, but we can evict the cookie by doing what I would call a cookie jar overflow. Basically, we are putting in so many cookies into this cookie jar until it gets full. And what happens when it gets full is that some cookies start to drop out. And the way that the browsers work is that it starts to evict all the cookies first, typically. So if an attacker from JavaScript writes a lot of new cookies, it can evict the HTTP-only cookie and then write a new cookie with the same name and value. So again, let's try to do that in a demo. So this time, let me use Chrome. And just because people say you should never do a live demo because things go wrong, I'm going to make it a bit harder and use Chrome because Cure 53 came out with a really good white paper on browser security this week. And on the way over here in the plane, I was reading the parse and cookie security in it. And they were also talking about this possibility to overflow the cookie jar and overwrite them. However, they said that this is not possible in Chrome, but it was possible in Edge and IE. So I'm going to try it in Chrome just because of that, because I think, from what I know, it did work for me before this morning. So let's just look at the version about Chrome here. So now I'm not connected to internet, so you want to upload, but you can see I'm on 61. I upgraded this morning, so it should be the latest version. So if I now go to this page here, we see that we have this cookie, the session cookie. So we're using express session here. So we have the connect SID value. And as you can see here, we have an HTTP only flag and a secure flag set. So what this means is that if we just simulate that we are on, that we're doing a cross-scripting attack, and I'm just dropping into the console here, we see that we are on this example.com domain. Now if we try to it's really hard one-handed, I'm not used to that. If we try to access this cookie now through document cookie, we see here that we can't read this. And it just gives me empty back. But we know that we have this cookie here because we have it in the cookie jar. So the reason why we can't do that is because of the HTTP-only attribute. So let's try again to set some more cookies. So let's try set a test cookie. Yeah, we can add a path too, just for the fun of it. Okay, so now if I look at the cookies, I see that I can only see this cookie. Because if you look at here, okay, what's the wrong value? Sorry? Oh, I can't see. Is that better? So here we see that we have these two cookies, and we have the connect SID marked with HTTP only, and the other one not marked. So from the JavaScript, we can only see and access one. So let's try to now overwrite the SID. Oops. So let's try this. So now we have this SID. Oh, perfect. Okay, do you hear me? Good. Okay, much better. So now we can try to now overwrite this connect SID from JavaScript. So let's try to do that. And then we try to look at the value, and we see that it's still not there. And the reason, again, if you look here, we see that, oh, just move this up a bit. We see that it's marked with HTTP only, so that's why we can't overwrite it directly from a script. So if you go back here now, I'm going to grab a script that I wrote. Now it will be hard for you to see, but let me just show you quickly what it does. So basically, we're trying to just specifying the target cookie name, the value we want to overwrite with. And what I'm doing here is that I first just store the previous cookies that I can access from JavaScript. So I store them in a variable, just a backup, because I'm going to overflow the cookie jar, and there are some previous cookies that I want to keep. So I put them aside, and then I start to overflow the cookie jar. So in this case, it will be about 180 that it can contain in Chrome. And then what I'm trying to do here is that I'm iterating, and each time I'm trying to set this cookie, and then I'm looking at, is this cookie set in the document cookie? If it's not in there, I know I haven't been able to overwrite it yet. So what I will do then is I will set a dummy cookie, and then I will iterate again. So once I've set enough dummy cookies to evict the original HTTP-only cookie, then I should be able to set this cookie and thereby overwrite it. And once this is done, I will then delete the dummy cookies I created, and then I will restore the cookies that I was saving from the beginning. Okay, so let's try now if this works. If I copy all of this, and we drop that into the console. So we can see now here, before we had the cookie test, and then we say we're overwriting it successful after 179 attempts, and the cookie jar then be restored. So if you now go to the application here and look at the cookies, we see that we have this connect SID overwritten, and it's no longer an HTTP-only flag or secure flag on it. So the point here I want to make again is that HTTP-only, although it's good in terms of protecting confidentiality, doesn't provide integrity protection. That's a good question. I mean, there's probably no good reason why the browser should allow anyone to overwrite an HTTP-only cookie from a JavaScript context. So the way they've done this, and I'm going to talk about that soon, in strict secure cookies. So some browsers like Chrome and Firefox, they implement protection for this cookie eviction attack for secure cookies from a non-secure origin. But the same has not been done for HTTP-only yet. And I think that would be a good addition to add to prevent this. Sorry?
Have you reported this to the browser?
No.
I suspect we'll fix it pretty quick.
Hopefully. Yes, but this is it's a known thing. It's just like the secure could be overwritten from non-secure origins. That's been known for like many, many years, more than 10 years.
Well, this is a browser security.
Yeah. So I mean, as they're doing updates and fixing the other things in terms of the secure attribute and be able to enforce that you can't overwrite a secure cookie from a non-secure origin, they should as well enforce that you can't overwrite and evict an HTTP-only cookie from a JavaScript context.
Do you have access to the browser Google, like the latest one?
So in terms of the strict secure cookies, I was speaking a bit with macOS, because at first I thought it was a bug. I actually filed a bug for Chrome, because when it came out, it said that it would work in both Firefox and Chrome, and it worked in Firefox. It didn't work in Chrome. I could still overwrite it. And then it turned out it was just not enabled by default yet. It was behind a debug flag. So then they enabled that a bit later. But yeah, I'll definitely send him a message to maybe look into this as well.
OWASP will help you.
Yeah.
Touch with that.
Okay, good. Yeah. Okay, so let's move on. A couple more. I know we don't have that much time. The next thing I want to talk about is the path attribute. So here again, the path is something that can limit the scope of the cookie to a specific path on a server. The problem is that some people may be tempted to use this as a way to isolate different applications. So let's say you have one server with multiple applications on, and you want to isolate them in terms of having them on different paths and scope the cookies to that path. Because that would be able to prevent unauthorized access to cookies from another app on the same server. Again, is this true or false? Well, it's important to understand here how this works, because cookie scope and the same origin policy are a bit different. If you look at the cookie scope, it's basically based on the host or the domain when domain attribute set, and the path attribute. So if those match for the cookie, the browser will send the cookie along. So in terms of this, it's fine. You can isolate these cookies for different scopes with the path attribute. But if you look at the same origin policy, it doesn't really care about the path, but it does care about the port and protocol on the other hand, which the cookies don't care about. So there's a discrepancy between the same origin policy and the cookie scope, which is quite important because this can lead to some vulnerabilities in terms of how we think we can limit the scope of a cookie. So let's say we have two different applications on a shared host, both on example.com. We have app1 and app2. So in terms of the cookie scope, these two are isolated because app1 is different from app2, and app2 won't see any cookies set for the path app1. However, in terms of the same origin policy, they're not isolated, they're the same. From the browser point of view, there's no difference between these two, they're the same application. And that means that app2 can exploit this in order to grab these cookies through the client side. So you can, for example, open a reference to app1 from the client side, and because it's on the same origin, you will have script access to that domain, and you can now request a cookie for that domain, and it will show you the cookie that's scoped to app1. The next one I want to talk about is the domain attribute. So sometimes I've seen this recommendation, and even in the OWASP testing guidance, I think it says that the domain should be limited and set to a specific host to make sure that the cookie is only sent to that server. So is that true or false? Well, not really, because what happens here is that if you actually set the domain attribute, it will be sent to that host, but not only that host, it will also be sent to all its subdomains. So of course, the risk here is a bit less than if you have a broadly scoped cookie set to the parent domain, because you hopefully have more control of your subdomains directly under your host. But there's still some risk, and the most probable risk I would see is that if, for example, you have an app hosted on www.example.com, and then you have a cookie scope to that domain, and then you may have like your dev or QA on dev.www.example.com, which is a subdomain to that. That means that your production cookies that were sent for your main domain might actually be sent to your QA environment or dev environment. And for some companies, that may be a big risk, especially if you have any type of sensitive information in production data that shouldn't be accessible in those environments. So the best way I would say to mitigate this is to remove the domain attribute altogether, because that should mark the cookie as host only by the browser. But it's important to know here that some browsers are different, and IE will always send it to subdomains regardless of this attribute. So keep that in mind. Okay, the last of these ones I want to talk about is cookie lifetime. So if we look at Wikipedia, for example, talking about session cookies, and with session cookies, I mean cookies that don't have an expire or max stage attribute. So it says that a session cookie, also known as an in-memory cookie or transient cookie, exists only in temporary memory while the user navigates the website. Again, is this true or false? So I have to admit that I believed this for a long time as well, that this was true and it was only kept in memory and was never written to disk. But when you look into it a bit more, you realize that what it actually says in specifications and how it works is that it's only kept as long as the session is alive, so to say, the browsing session. And who decides when the browsing session ends? Well, it's not necessarily you when you close the browser. It's up to the browser how to do that. And in fact, non-persistent cookies may actually be persisted to survive a browser restart, perhaps even a computer reboot. And now if you look at specifications on Mozilla for the developers there in terms of cookies, they explicitly make it clear to you that you have to expire these cookies and validate them on the server side, and don't rely on the client to do it, because the client might keep these cookies longer. And there's some features, for example, if you ever had your browser crash or so, you might notice that when you restart it, it gives you an option to restore your sessions previously, and all those sites you were logged into are still working, although they might have session cookies. So even if you had like a multi-factor authentication and very strong authentication, it typically comes down to one single cookie or two that keeps track of your session. And it may be that it gets persisted, and even if you close the browser, someone may be able to later just open it and be directly logged in again. So that's why it's really important on the server side as a developer to clear these cookies and make sure that you invalidate the session that associated with them after a certain time period. So those were some of the, so to say, misunderstandings or myths about cookie security that I've come across, and they're quite common. So let's see what's actually being done to improve this and make things better. So as I mentioned before, there is at the moment a draft of a new update to this RFC 6265 in order to improve this cookie recipe. So there are three main things in there. The first one is something that was called strict secure cookies. And if you remember the first attack I showed you when I was overwriting the secure cookie for the CSRF token, this is something that would prevent that. Because according to this, you can't set a cookie marked with the secure flag from a non-secure origin, which makes perfect sense. And also it prevents you from overwriting a cookie marked with a secure flag from a non-secure origin. And also it prevents you from evict a cookie marked with a secure flag from the browser jar, cookie jar, from a non-secure origin. So it would have prevented this attack. However, there's still a window of opportunity, because for this token, for example, even if I couldn't overwrite it in an active man-in-the-middle attack, I could have set it if the user hadn't been logged into this page yet and had that cookie set by the site. So I could set it with a long expiration, and then I knew what the user would have in terms of the value, because I planted that. And then later on in a different session, when the user is logged into the page would not issue a new token because it already provided a token in the request, and then I could create still a valid attack. So it leaves a window of opportunity for attackers before the real cookie is set. So the next thing that's also in this specification is the cookie prefixes, and this will fix this. Because one of the problems we have with cookies that I pointed out early on is that we can set different attributes, but the server will never see them when they're sent to the server. So there's no way for a web application server to know whether a cookie has been set securely and to know that it's the right cookie that it expects. So the solution here in a backward compatible way is to smuggle information in the name of the cookie. So rather than changing the specification and adding new things that would break existing implementations, we simply make a convention of the name. So we can prefix the name of the cookie with either secure or host. A bit unfortunately, I would say perhaps, is that the host attribute is actually more secure than a secure attribute. So we don't seem to make this with security easy for developers. But what it means here, the first one, secure, is that the cookie must be set over an HTTPS connection, and it must contain the secure attribute. So if you have a compliant browser, the server can be sure when it gets a cookie with this prefix that it has been set over a secure connection and it has the secure flag set. The host prefix does the same, but in addition, it also enforces that it doesn't have a domain attribute. So this cookie is strictly scoped to just one host, and also the path attribute has to be set for the full application, for the full host, so to say. You can't specify it to a more precise path. So of these two, I would say that unless you absolutely need to share a cookie between domains or different subdomains, then the host prefix is the one to use, is the most secure one. The last one of this is called the same site attribute. And the problem we try to solve here is that cookies, as I said before, are sent with each request to a server for which it was set, regardless of where that request originated from. Even if it was from your legitimate application or from another page that the user was visiting another domain. So attackers can abuse this by initiating authenticated cross-origin requests. For example, in cross-request forgery attacks or cross-site script includes, and other types of attacks where we try to take advantage of this. So the solution here is to add an attribute called the same site. And it's two modes, the strict and the slacks. What it does is that it prevents a cookie from being included in requests cross-origin. So only if you set in strict mode, for example, the cookie will only be included whenever the request is originating from within your site. So on postbacks and things like that, it will be included. But it won't be included when it's originated from another site or when a user clicks a link and so on. And that may break some application functionality and some expected behavior applications that users have come to know. So that's why there's also a possibility to set it to lax, which is less strict. And that means that it will include a cookie for cross-origin requests when it's a safe HTTP method. In other words, when it's a get or head or options, but not for post requests. So that will reduce the effectiveness against a cross-site request forgery attack, because if you have any kind of state change made with one of these so-called safe HTTP methods, like in a GET request, you could still perform that type of attack. So what I would say is that the same site attribute is not perhaps the ultimate cross-request forgeries layer and prevents that forever. I think it's a really good thing. I think it's a thing that provides defense in depth and that we should use. But there may be situations and types of applications where it's not appropriate, and also be aware that most browsers don't support this yet. So far, I think it's only Chrome and Opera, I guess, that would support it. But I think there's work being done, and I hope Firefox soon will adopt it, and eventually I hope that Internet Explorer and Edge will do as well. Okay, so let's quickly summarize the key takeaways. So first off, we talked about cookies and that they're still today largely based on a very old draft from '94. There were attempts made to improve this, but they were not adopted really, and we still basically use the same mechanism that was drafted in '94. And this was at the time before application security was a thing. And we didn't, at that time, anticipate the way cookies would be used today and the importance they have in terms of application security. So unfortunately, this means that the cookie security model has a lot of weaknesses, especially in terms of integrity. And that's why it's very important that when you build web applications, don't do that on false assumptions regarding cookie security. Make sure that you're aware of these different pitfalls and especially how the integrity can be compromised of a cookie. So never assume that the value you get in a cookie is untainted and non-malicious. You should always try to validate that or provide signing of cookies or another mechanism to make them more secure. Also, I would like to encourage all application developers and framework developers to adopt and take advantage of these new improvements. For example, if you are a framework developer, try to perhaps by default use the cookie prefixes as default name for your session IDs, for example, to make sure that they're only set over a secure connection and maybe scope to the host only. Or at least provide a mechanism for your developers to change the name of this cookie so they can adjust it and add these cookie prefixes. Also, perhaps start using the same site wherever appropriate. Because the more we do this, I think it will provide a defense in depth, and as more browsers adopt this, it will make our web applications much more secure. But at the same time, be aware that for now at least, not all browsers are baking cookies according to the same recipe, and there are some differences, and not all browser support is yet. So until we have full adoption and support by all modern browsers, you need to provide additional defenses. For example, if you implement same site, you still would need some other type of cross-request forgery protection. So for now, I would see it as a defense in depth rather than a replacement for a more traditional defense. Okay, before we end, I just want to provide what I would see perhaps as the ultimate cookie configuration. Is there such a cookie configuration? Well, there may not be an ultimate configuration that's the right for every application or that's the best one, but this is, I think, what's the best we can probably do at the moment. So first of all, okay, I see now that these markings became a bit wrong because we just changed the aspect ratio. So it should mark the host. So first of all, we have the host prefix on the name, and that means that it will only be scoped to a particular host, and it also means that we have the secure attribute must be set and the path attribute set to the root of that application. So this can only be set over secure connection and only scoped to a particular host. Also, we have the HTTP only attribute, which means that we can't access this cookie from JavaScript. And we also have the same site attribute, which means that it won't be sent on cross-origin requests. So this will protect us pretty much against everything except from a cross-scripting attack where we can still overwrite a HTTP-only cookie. But it would protect confidentiality and integrity from a network-based attacker. It will protect you against malicious subdomains, and it will protect you against cross-site request forgery types of attacks. Okay, that's all. Thank you very much. Any questions?
All right, thank you, David. We have a few minutes for questions, and I have a mic here I can provide to anyone who wants to ask one. And since we lost our stand, I guess I'll run around.
Hi. So in the wild, how prevalent are these cookie attacks currently? Do you have a sense of? They seem pretty straightforward within current cookie stuff.
Yeah, unfortunately, I don't have any data in terms of, excuse me, in terms of attacks and how common it is. Like, I mean, it's quite easy to do. I mean, a lot of this, especially if you, as a man-in-the-middle attacker, you can overwrite these cookies. But I don't know actually how common it is that people carry out this type of attacks. I don't have that type of data. In terms of that, I also want to just point out that the overwriting of the secure cookie is actually mitigated now in Firefox and Chrome and Opera because they implement the strict secure cookie specification. But in other browsers, you can still do this.
Any other questions? Oh, all right.
Hi. In the environments that I've been in, we have a lot of reverse proxies that are managing the cookies, and I wondered about this same site attribute. What normally happens in many configurations is the reverse proxy gets the cookie and then it sends it downstream to all the things that were behind it, and those things that are down behind it, I guess, would have to be very liberal in what they would accept from the reverse proxy. And I'm wondering, like, what you see about reverse proxy configurations and whether, you know, this is intended to work at all in that environment.
That's an interesting question. Yeah, I haven't looked at that in the context of a reverse proxy, but in terms of the browser, we'll only see like the first step, right? So we'll see the, it'll treat it as the, depending on the URL that you're going to, that's what it will see as the target domain that we'll go to. And so it's what happens after that. If that's then sent to different applications that are located on different servers, the browser won't have any visibility into that and it can't make any decision on that.
Thank you.
All right, we're out of time. If you have more questions, feel free to come up. And let's give David a big thank you for speaking.
Thank you.